The lesson objective for this video, students will use properties of rhombi, rectangles, and squares to solve problems. So first of all, rhombi, rectangles, and squares, these are all special parallelograms. They're all special parallelograms. So everything that's true of a parallelogram is going to be true of a rectangle, a rhombus, and a square. So let's first look at some definitions. A rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And then finally, a square is a parallelogram with 4 right angles and 4 congruent sides. So that means if a quadrilateral is a rectangle, and a rhombus, if it's both of those, it's a square. So one way you could think of it is we have the family of parallelograms, and within those there are 2 special types, a rhombus and a rectangle. And then if it's both of them, it's a square. Or we could also think of it with a Venn diagram. I can do that too for you. So if we have this whole family of parallelograms, within that we have rhombi, and we have rectangles, and then where they overlap are squares. So that's 2 different ways you could think of the relationships of the special parallelograms. So we can use this information to solve some problems and to determine what kind of special parallelograms we're dealing with. So in example 1, we've got, for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So I'm going to draw a rhombus which has 4 congruent sides, and then opposite angles are congruent because it's a parallelogram. And then I'll go ahead and label it RSTV. So angle S is congruent to V. That's always going to be true because opposite angles of a parallelogram are always congruent. So that's always true. Opposite angles of a parallelogram are congruent. Then if we look at angle T and angle V, we can see that these are consecutive interior. So if the rhombus does not have right angles, then those two are not going to be congruent. But if the rhombus has right angles, they would be. So that's sometimes true. Because if it was a square. When it's a square, that would be true. But if it's just a rhombus that's not a square, it would not be true. Okay. Next, we're going to classify this quadrilateral. So I can see that I have 4 congruent sides, and they have one angle that's 127. That means that the opposite angle is also 127. And the 2 angles going side to side have to add up to 180. So 180 minus 127, and we're left with 53 for the other angles. So clearly it's not a square, so it's not a rectangle, but it has 4 congruent sides, therefore it is a rhombus. Here's another one. Here's one for you to think about. Based on the given information, what would be the classification for the figure I just drew? It's a rectangle. Now, some of you might have been tempted to say it was a square, but I did not mark the sides congruent, even though I drew it kind of looking like they were congruent. All that's marked is that we have 4 right angles. It does not say that the sides are marked congruent, so sides are not marked as congruent. So rhombi have some special properties. The first one is that the diagonals are perpendicular. So in my figure, I know that AC would have to be perpendicular to BD because ABCD is a rhombus, although it's not marked. I should mark that all these sides are congruent. The other thing we can say about rhombi is that the diagonals bisect each pair of opposite angles. So in my figure here, AC is bisecting angle DAB and angle DCB, and BD is bisecting angle ADC and ABC. So we end up with 2 sets of 4 congruent angles. ADB and BDC are congruent, as well as being congruent to DBA and DBC. And then on the other angles, angle DAC is congruent to angle CAB and congruent to angle ACB and angle ACD. And again, because it's a rhombus, we know that they make a right angle in the middle. When we have a rectangle, the diagonals are congruent. And so AC is congruent to BD. And then the pieces end up being congruent also, since diagonals bisect each other on a parallelogram. They're congruent to begin with, and they're bisecting each other. So all four of these pieces end up being congruent. So if I give you a rhombus FGHJ, what are all the things that we know because it's a rhombus? Well, first of all, we know that the four sides are congruent. So we have FG is congruent to GH, which is congruent to HJ, and congruent to FJ. All four sides are congruent. I know that if I draw my diagonals here, I know that FH would have to be perpendicular to JG. I'll go ahead and label this point M here. It's a parallelogram, so I know that both pairs of opposite sides are parallel. So I know that FG is parallel to JH, and I know that FJ is parallel to GH because it's a parallelogram. And also because it's a parallelogram, I know that opposite angles are congruent. So angle FGH is congruent to angle FJH. Got my little angle sign there. And I know that JFG, angle JFG, would have to be congruent to angle JHG, because opposite angles on a parallelogram are congruent. And then, because it's a rhombus, I also know that all of these angles here are right angles. So angle FMJ, angle JMH, angle HMG, and angle FMG are right angles. I also know that the diagonals bisect the opposite angles, so that means that those angles are congruent there, and these angles are congruent here. So I'm running out of room, so I'm not going to write that down, but those angles would all be congruent because it's a rhombus. All right. And if we look at a rectangle, there's all kinds of things we know about the rectangle as well. Looks like my letters got messed up though somehow. Oh well. So for the rectangle, everything that's true of a parallelogram would also be true for my rectangle. So rather than list those all out, just go ahead and say that. Everything true of a parallelogram. So for what I mean by that is that the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, and the diagonals bisect each other. But in addition to that, I also know that angle A is congruent to angle B, which is congruent to angle C and congruent to angle D, because they are all right angles. And I also know that if I draw my diagonals, that they would also be congruent. So AD would be congruent to CB. So now let's use these properties to solve some problems. So we're going to classify the special quadrilateral, explain our reasoning, and then find the values of x and y. So if I look at the figure I have for example A, I can see that 4 sides are marked congruent, but I don't have any angles that are right angles. I'm given the 97 degrees, so none of them are going to be right angles. So that means that it has to be a rhombus because it has 4 congruent sides. All right, so then if I want to find the value of x, well, I've got this side is 5x plus 6 and this side is 8x. And because they're congruent, I know that those expressions are equal to each other. So that means that 8x would equal 5x plus 6. Subtract the 5x, we get 3x is equal to 6, and so x equals 2. And my angles are consecutive angles. So they're not going to be equal to each other, but instead they're going to add up to 180. So 12y minus 1 plus 97 has to equal 180. And so 97 minus 1 is 96. We subtract 96 from both sides. We get the 12y is equal to 84, which means that y is equal to 7. Okay, one more for you to take a look at. All right, so this one has all 4 sides congruent and all 4 angles are right angles. So that means that it is a square. Four congruent sides and 4 congruent angles. And so because my opposite sides are congruent, I know that 2x plus 1 and 4x minus 7 would have to be equal to each other. So 4x minus 7 equals 2x plus 1. We subtract 2x from both sides and add the 7 to both sides, and we get 2x is equal to 8. So when you divide, you get x is equal to 4. Now if we look at the angles, they've told me that this angle up here is 7y plus 3. Well, because it's a square, it's also a rhombus, and that means that the diagonals are bisecting the angles. So they're bisecting that 90 degrees, which means that 7y plus 3 is going to have to equal half of 90, or 45 degrees. So when you subtract 3, we get that 7y is equal to 42, and y equals 6. And that concludes this video. Thank you.